Hello students. So today I am going to explain to you about a very basic concept, that is the uh, atoms, basically focusing on atoms. So let's go to the next slide. So students often use the term atomic mass, but they really don't understand exactly what is meant by the atomic mass. So it's not clear in their head. So yeah, I'll try to explain that to you. So the first thing is that how do we know the mass of an atom? Can we really weigh a single atom, or can we weigh a collection of atoms and then divide them by the number of atoms and then find out the atomic mass? So you can know that actually it is quite impossible, because the atom is so very small that it's impossible to weigh it as a single atom. So when we say that the mass of oxygen atom is 16, then what is meant by that? What is this 16? 16 what? 16 grams, milligrams, kilograms. What does it mean? So let me explain to you that this 16 is actually a relative atomic mass. It's a relative atomic mass, right? So what do we mean by the relative atomic mass? This is, I'm going to explain you by a simple example. How in the olden days the scientists were able to calculate or write down the atomic masses, when the present day sophisticated instruments like mass spectrometer were not available. So how they were finding out? So I'm giving you a simple example, that when they decomposed hydrogen chloride gas, they collected hydrogen gas and chlorine gas, and they found out that the masses of those gases were in the ratio of 1 is to 35.5, which means that the hydrogen and chlorine, their masses are in the ratio of 1 is to 35.5 when they have combined. So if we just assume that the mass of hydrogen atom is 1 unit, then on that scale the mass of chlorine must be 35.5. The formula is HCl. That means one H is combined with one Cl. So this ratio of the masses indicates that if we consider the mass of hydrogen atom to be just one unit, then on that scale the mass of chlorine should be 35.5. That is what is meant by the relative atomic scale. Actually, if you wanted to know the mass, actual mass of a hydrogen atom in grams, and it would be so small as 1.67 into 10 raised to minus 24 gram. But how it has been done, that you will understand slowly later on when you go through the detailed part of the syllabus. So these relative atomic masses are actually what we talk about. Now, what is the standard reference for this relative atomic mass? In our example, we considered the mass to be hydrogen, the reference atom to be hydrogen, but slowly, gradually, as more studies were carried out, it was found that hydrogen was not a suitable standard. You don't bother about the reasons. But now, most currently, the latest scale, or the latest reference point for making the atomic mass scale is actually the mass of an atom of carbon, that carbon atom, which is an isotope of carbon, and it has a mass of 12. That means it has 12 neutrons, 12 protons. So that carbon 12 is actually carbon 12 is actually that atom of carbon which has 6 protons and 6 neutrons. So that makes it a total of 12. That's an isotope of carbon. So that has been taken as the standard, and it has been assigned a mass of 12 units. So we say the atomic mass of carbon is 12 units because that's our reference point, and it is 12 times heavier than what we had considered before, the hydrogen atom. So now on that scale, carbon has a mass of 12, and all other masses are relative to this mass of carbon. So for example, when we say that the atomic mass of oxygen is 16, it means that in comparison to the atom of carbon whose mass is 12. And when we say that the atomic mass of magnesium is 24, then it means that one atom of magnesium is twice as heavy as an atom of carbon, and a carbon atom is 12 times as heavy as a hydrogen atom. So everything is a relative atomic scale, but sometimes you will find that the atomic masses are fractions. Like for example, for chlorine, we say that it is 35.5. So how can it be 35.5? Basically, it is due to the presence of isotopes. Now, what do you mean by isotopes? See, isotopes are the atoms of the same element that have the same atomic number but different mass number or different number of neutrons. For example, if you see here, we have got three isotopes of carbon. All the atoms have the same atomic number, which is 6. That means they all have 6 protons. But the number of neutrons is different. So this atom has 6 neutrons. This atom has 13 minus 6, that is 7 neutrons. This has 14 minus 6, that is 8 neutrons. But neutrons really do not play an important role in chemical reactions. So it is the atomic number, this 6, which actually matters. So these atoms have the same atomic number but different masses, and these are isotopes. Similarly, nitrogen, you can see that there are 3 isotopes. Oxygen also has isotopes. So due to the presence of these isotopes, what happens is that the masses are actually not exact whole numbers. For example, how did we find that the atomic mass of chlorine is 35.5? That is because chlorine has 2 isotopes, chlorine 35 and chlorine 37. But the average should not be considered as 36 because they are not present in equal abundance. What I mean is that out of all the atoms present in nature, 75% atoms are of chlorine 35 type and 25% atoms are of chlorine 37 type. So when you will take the average, it will be called as the weighted average. So how do you calculate the weighted average? If you have 100 chlorine atoms, then 75 of them have a mass of 35 and 25 of them have a mass of 37. So weighted average is 75 into 35 plus 25 into 37 divided by 100, that is 35.5. So that's how we say that the atomic mass of chlorine is 35.5. So hope you have understood the basic idea of the atomic masses, the concept of relative atomic scale and the concept of isotopes, which helps in finding out the fractional atomic masses. If you have understood properly what I tried to convey, please comment and like the video. Thanks very much for watching.